Okay. Again. As always, some of you have seen this before, some of you haven't. So I'm going to pretend, as always, that you haven't seen it before. If you have already seen what I'm about to do, don't give away the surprise for the people that haven't seen it, please. This construction right here is 9 with the exponent 1/2. So that means you're going to take 9 and you're going to multiply it by itself half a time. That makes no sense, right? We've already come across things that don't make sense in exponents, like negative exponents. Math guys figured out a way to explain it to us. They've done the same thing here, all right? With your calculator, get this answer. So you need to push 9, then whatever your exponent button is, and then just don't hit 0.5, okay? Do bracket 1 divided by 2, close brackets, and equals. And what do you get? 3. Now, for 27, do the same thing, but it's not 1 divided by 2, it's 1 divided by 3, right? So it's 27, exponent button, bracket 1 divided by 3. And what do you get? 3. If you're not getting these numbers, you're doing something wrong with your calculator. And this one, 625, exponent button, bracket 1 divided by 4, close brackets, equals 5. Now you guys are smart kids. Is there another relationship with 9, 3, and an exponent? An exponent between 9, 3, and an exponent. Is there a relationship there? What is it, Sydney? 3 squared equals 9, yes? And if that is true, then its inverse must be true, correct? Which is the square root of 9 equals 3, yes? Everybody still agrees with me? Okay. The square root of 9 equals 3. What else did we just find out equals 3? 9 to the 1/2 also equals 3, yes? If this equals 3 and this equals 3, then what do we know about these two? They're the same thing as well. So the square root of 9 must equal 9 to the 1/2. Yes? Okay. Now, if that is true, then what does that tell us about 27 to the 1/3? Look at this. Somewhere on this side that I've highlighted in green, there are 2 numbers that we don't write. Where are they? We don't write that 2, and we don't write that 1. But if I wrote them, you would notice there's a 2 and a 1 there, and there's a 2 and a 1 there. So here I have a 3 and a 1. I know now that roots are related to fractional exponents. So I know that this base will become the radicand, and I know that this exponent will show up somewhere in this construction. Where does it go? If it happens once in math, how often does it happen? Every time. So in this one, when I had a fraction, the 2 became the index. So what is that 3 going to become? The index. The 1 became an exponent. So what does that 1 become? The exponent. Everybody with me? So the next one was 625 to the 1/4. So that's the 4th root of 625 to the 1st power. Everybody cool? There's some of you in here that may not have seen that before. I hope not, but if there is, if you do exist, you have now seen it. What's the rule? X to the y over z equals the z root of x to the y power. The denominator becomes the index, the base becomes the radicand, the numerator becomes the power. Is there anybody in here that hadn't seen that? Okay. Got it? It's pretty easy, right? Like, you can explain it. You can even see why it works. Everyone's good? All right. So let's see about this. Now, mine printed weirdly, A, B, C. Did your guys' do that? Yeah. Sorry about that. So A is 0.04 to the 3/2. Now, that looks different, doesn't it? But have looks mattered in math before? Or do rules matter? The rules are what matters. So when we add just a regular number there, we took the denominator and it became what? What happened to the denominator here? Became the index. So the denominator here is 2, so what's the index? 2 square root of what? The base, 0.04, and all of that is to what power? 3. What is the square root of 0.04, sorry? No. Oh, you've given me the whole answer for was. Stop it. What's the square root of 0.4? 0.2 cubed, and as Fawaz says, that's 0.008. Everybody good? Let's check B. 27 to the 4/3. Where does that denominator go? To the index. So I'm looking for a cube root of what number? 27. And what power am I going to put that to? 4. Oh, sorry. What kind of, because I was thinking about this. Damn it. And what power am I going to put this to? 4. Brilliant! Now, what is the cube root of 27? You all know this already. What is it? You have it memorized. 3. 3 to the 4th power. 3 to the 4th power is? 3 times 3 is 9. Yeah, 81. Everybody cool? Now, do you get to forget about the previous 7 rules about exponents when we add a new rule? Are you allowed to forget about the previous 7? No. So that's where we are right here. What do I do with exponents over brackets? Multiply. So inside the brackets I have 1/3, and now I'm multiplying it by 2. So what do I have? 2/3. So I have 8 to the 2/3. Now, do I just follow the new rule that we just learned? Yes. Where does the 3 go? Index. Cube root of what? To what power? 2. What's the cube root of 8? 2. To what power? What's 2 squared? 4. Can everybody do this? It's easy peasy, right? So let's check this one out. Does anything change even though it looks different? No. This is saying the square root of 0.49 to the 1st power. What's the square root of 0.49? 0.7. Can you do that with a fraction? I'm not asking you if you can. If you are able. I'm asking you, can you turn this into a fraction and still do this work? Yes, because what is that as a fraction? 49 over 100. And if I want the square root of that, it's 7 over 10, yes? And 7 over 10 and 0.7 are the same thing. Cool? All right. Okay. Again, rules don't change. This looks different, doesn't it? But is it? No. Because what is 1.5 really? Half? 1.5. So isn't that really 16 to the 3 over 2? Right? And now do we know what to do with that? Yep. Where does the denominator go, Harmeet? The front part of the square root thingy. It's okay. That's why I picked you, actually. Because I know you know how to do it, because I'm hearing you tell me. But if I write on a test, what's the index? Right?
It's a small part in the front.
There you go. Okay. So at square root of what? 16 to what power? 3. What's the square root of 16? 4 to the third power, which is 64. Huda? Great. What about this one? 81.75. What are you talking about, Myers? What is it really? Pardon? 3/4. What's the fourth root of 81? Cubed. Now let's pretend you don't know the fourth root of 81. You don't have it memorized, even though we just did it right up here. Then, what do? If you don't know this in your head, what do? You simplify it the way we've been simplifying these things in the past, yes? I would need a group of 4, right? So I factor that and get 3 times 3 times 3 times 3. Is that a group of 4? So out it comes. Did I leave anything under there? No. So this is 3 cubed, which is what? 27. Is everybody good with the easy ones? Okay. Now, you guys aren't stupid. When we're dealing with radicals, it's entirely possible that we'll have an irrational number, yes? Right? And these exponents are all fractions, yes? And a fraction exponent, we have just proven, gives us a radical, yes? So is it possible that a fraction exponent will give us an irrational number? Yes. And that's what's happening down here. Okay? What is this really? Where does the 5 go? 5th root of 8 squared. Does 8 have a 5th root? No, the biggest root 8 has is the cube root, right? So this right here is irrational, isn't it? So once we know that that's irrational, we know we need a calculator. You can't do these without a calculator because it's not a real number. It goes on forever. So how do we punch that into a calculator? We've already practiced it when we were proving the last thing. It's base, exponent button, bracket, numerator, divided by denominator. And then you're going to get a crazy decimal. I don't care what the decimal is, right? The point is I just want you to know how to do it. What is it? 2.3? Okay. But it's not really. It's 2.3 blah, right? So 2.3 blah. What about the next one then? What do I punch in? 0.6, exponent button, bracket, 15 divided by 7. And you're going to get blah. What is it? 0.334? Okay. Blah. Is everybody cool? Active, hit me. Well, because the 5th root of 8, you know doesn't exist. It can't. Because the biggest root 8 has is 3. So it has to be irrational. Okay? When you write it out properly, well, this one is the 7th root of 0.6. Can't possibly exist. Right? Okay. I don't care about page 105. Skip it. And then there's a bunch of work. Okay, but I don't want you to do that work yet. Skip to 108, please. We're going to do 108 as notes, and then you're going to do some work. Okay? Everything on page 108 looks weird. Do looks matter? No. We follow the rules. What do you notice about that and that? They're the same base. We know what to do when the bases are the same. What do we do? Add the exponents. So what is the answer here? 0.3 what? Squared. What is 0.3 squared? 0.09. Why is it 0.09, David? What is this really? Pardon? Yeah, but what is it really? No. 0.33333 is 1/3. That is really 3 over 10, yes? And 3/10 squared is really 3 over 10 times 3 over 10, right? What's 3 times 3? 9. What's 10 times 10? 100. 9/100ths, which is that. I need you guys to be aware of that. I know that basically because kids don't like them, we don't stress fractions anymore. Even though fractions are really what the world works in, not decimals. All right. Number 2 is freaky deaky looking, isn't it? If I gave you number 2 on a test, you'd be all like, wouldn't you? Don't lie. I just gave you an exponents test and you all went when I handed it to you. That looks scary, doesn't it? Until you look closely. What do you notice about that and that? They're the same base, aren't they? So isn't this question exactly the same as a to the negative 4 squared and a squared oh, I screwed it up. I wrote it out wrong. A to the negative 4 squared times a squared cubed. Isn't it exactly the same as that? What would you do there? Multiply. So you'd have a to the negative 8, yes? What would you do there? So you'd have a to the 6th, yes? What would you do there? Add. So you'd have a to the negative 2, yeah? Which then would flip this over and it would become 1 over a squared, yes? Everyone agrees? Okay. So apply that to this situation. What's a? It's negative 3 over 2, isn't it? So I have 1 over negative 3 over 2 squared. What happens when I square a negative? It becomes positive. So I have 1 over 9/4, right? Everyone agree? Well, 1 divided by 9/4 is what? 4/9. You can do it in your head. Right? Let me show you another way just to be safe. Not responding. Highlight, delete. Forget about that a. Let's do it this way. Negative 3/2 to the negative 8. Negative 3/2 to the 6th. Negative 3/2 to the negative 2. What does that negative 2 do to a fraction? Just did it on your quiz. What does a negative exponent do to a fraction? Flips it. So this becomes 3 over 2, 2 over 3, negative 2 over 3 to the positive 2. Square a negative, and then square everything inside, 4/9. Now please look at that question and take some time to really look at it. because when you look at it for the first time, it looks crazy hard. If you were to walk that up to people on the street, they would say, I haven't been able to do that math since I was your age. Nobody could do that math. But when you look at it and you think about it, you can do it in 2 steps, right? And everyone would think you were a wizard. Look at the next one. Looks scary. Is it? Why? It's all the same base, so the regular rules apply. So I got 1.4 to the 7th up top over 1.4 to the negative 2. What do you do with those exponents? Add them. But it becomes addition, so it's 1.4 to the 9. Right? Everybody cool? All right. And we're just going to leave it right there because I only care about the exponent laws in this unit. What about this one? Looks scary. Is it? Why? Because it's got fractions. Fractions hurt my brain. But they're not. Are they all the same base? Are they all the same base? And so on the bottom here, what do I do with 1/3 and 5/3? Add them. What is 1/3 plus 5/3? 6/3. 6 divided by 3 is 2, isn't it? So I had 7 2/3 over 7 squared. What math do I do there? Subtract. Now, stop for a second. This is in thirds. So what does this need to be in to do subtraction? Thirds. We already had it in thirds, didn't we? So we leave it as 6/3. What's 2/3 take away 6/3? Negative 4/3. Yeah? Do we know what to do with negative exponents? Yes or no? We know what to do with negative exponents. Do we know what to do with fractional exponents? You guys are mixing things up. Negative exponent does what to this 7? Flips it. So it's going to become 1 over 7 to the positive 4/3, yes? Now, what do we do with a fractional exponent? Where does the denominator go? To the... No, guys. No, guys. We just did this 30 seconds ago. Where does the denominator go? To the index. So where does this denominator go? Index. So I have 1 over the cube root of what? 7 to what power? 4th. And that's done. Why is it done? Because, Ekdeep, is there a cube root of 7? So it's irrational, so we stop. Got it? You want to stop. Yes. All right, here's an easy one. Just to remind you of how easy exponents really are. What is it? X5 and Y? Negative 2. Is that allowed? Which one, Harmeet? Only the Y. X to the 5 over Y to the positive 2. Maybe I should give one more exponent quiz. Huh? Did your guys not print the little A there? Damn, what the hell? There's supposed to be a little A there. Not responding. Little A there. All right. These mess you guys up, and I don't know why. You've done enough math. Coefficients go with coefficients, and like terms go with like terms. That shouldn't be that complicated, and yet people have trouble with it. What is 10 divided by 5? 2. 5 minus 3 squared. 3 minus 2. b to the positive 5. And it's done. Yes. What's 10 divided by 2? Because, remember, a lot of you are still doing that when you divide with exponents, right? Even though I drew it out, I explained to you that a cubed divided by a is a over 1a. Cancel. The subtraction thing is a shortcut. It's what you're doing. It's not what is happening mathematically. Do you understand? So this 10 over 5 is technically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 ones, right? Over how many ones? 1, 2, 3, 4, 5. Cancel, cancel. Leaves you with 5, right? Except that's not what you're doing, because that would be subtraction, right? It's 10 divided by 5. So I take that 10 and I divide that 10 into 5 groups. 5. And one of those groups is 2. The reason we subtract with exponents is because exponents, oops, that was the right answer. Exponents are a shortcut to multiplying. It's not adding. Okay? Maybe this will help you. 10 over 5 is the same thing as 2 times 5 over 5, isn't it? What would happen to those two 5s? Cancel. What's left? The 2. Maybe that'll help. I don't know. I don't know how to explain to you guys that this is division, and this is still division, but the shortcut to doing this division is we subtract the exponents. That's not what we're actually doing. Everybody cool? Again, if you're not, just figure out the shortcut. Okay, this is tricky here because it looks weird. What do I do there? What's negative 3 times negative 5? Positive 15 over 1.5 to the 5. What do I do here? Subtract. What's 15 minus 5? 1.5 to the 10. Excellent. What about here? Where does that 1/3 have to go? To everything. Does that everything include the 8? Yes. So what do I really have here? I have 8 to the 1/3, right? What do I do over brackets? Multiply. What's 3 times 1/3? 3/3, which is? What's 3/3? 1. So this is a to the 1, isn't it? And what's b? 6/3, which is 2. B squared. Am I done? No, because this has no variable, so I should try and simplify it, right? Where does that denominator go? Index. Cube root of what? To what power? 1. What is the cube root of 8? 2. 2 to the first power. Do I ever write the first power? No, so it's 2a to the first power. Do I ever write the first power? No. B what? Squared. Done. Now, if I gave you that yesterday, even before without teaching you this, a bunch of you would have screwed that up. Even though you know the rules. Just slow down and think about everything, right? What about this next one? What do I know about numbers, bases, and other bases? They stay together, right? Numbers divide. So what do I do with the yellow stripe? What's 4 divided by 2? 2. Excellent. What do I do with the green stripe? Subtract. What's negative 2 minus 2? Negative 2 minus 2, guys. Negative 4. And 2/3 minus 1/3. B to the 1/3. Now I sort this out. Anything that doesn't make sense has to be fixed. Does 2 make sense? So he doesn't change. Does a to the negative 4 make sense? No, because a can't have a negative exponent. Where's it going to go? To the bottom. B to the 1/3. Can I leave it that way? Yes, that's okay. Is there another way I can write this? What is it? Cube root of b, right? So I could rewrite this as 2 cube root b over what? A4. These are the same. This guy is exponential form. And this guy is radical form. How do you know which one I want? Where will you find that out? In the question. What if it doesn't say? Then what? Then it's either one. Everybody got it? All right. Look at B and tell me, don't start it yet. Talk to your neighbor. What do you want to do with that question? Because there's about 5 ways you could do it. I'm serious. Take a second and talk to somebody about how you would do that question, because that's a complicated question. And then I will ask if anybody would like to say what they would do. Remember how I said somebody got 20 out of 20 and didn't put their name on it? Guess whose it is? Mine. It's the key. I marked it. Wow, this kid's doing awesome. I'm a little stupid by the end of the day. Shut up! I used to do a joke like that because I would write key on things that were the key, and then I'd be handing him back and say, man, this kid Key is super smart. And then I made a joke that if I have another kid, I'm going to name him Key. So when he writes on tests, his name, Key. Get it? I've had a lot of jokes like that. I was going to name my first son Watson. So on the first day of kindergarten, he could say, what are we doing today, Dad? And I could go, elementary, my dear Watson. Get it? Sherlock Holmes, elementary, my dear Watson. I also wanted to name a kid Jeeves. So on the first day, he got his driver's license. Where to, Dad? Home, Jeeves. That's what butlers are named, Jeeves. You guys are no fun. All right. So, thanks, buddy. And it's an old search engine called Ask Jeeves. I don't even know if it still exists, does it? I'm going to check in your first break, see if Ask Jeeves still exists. No, that's not. They tell you that, but it's not really true. No, because companies do disappear from the internet. Yes, there will be cached pages of Ask Jeeves searches, but the actual Ask Jeeves search engine might be gone. I mean, really, I don't know why any search engine exists anymore other than Google. Even Bing tries, but Bing sucks. Google should, all of you should recognize how evil, well, not evil, how potentially evil Google is. Because if you haven't figured it out yet, you should. One time, I told you guys, I'm going to California in August. I'm taking my kids to Santa Cruz. So I Googled once to find out how much it costs to go to the Santa Cruz amusement park. Now, every time I play a game on my phone, Yahtzee, Scrabble, anything, guess what commercial comes up on the ads? Santa Cruz amusement park ads. Because I Googled it once from my phone. But by the time you guys are my age, you're going to have glasses that are screens. And when you drive down a highway, all the billboards will be blank. Except you'll see something that has been in your search history. So when I drive down the highway, on my glasses will be projected on that billboard a picture of the Santa Cruz amusement park. No, it's coming. There's already people working on it. Yeah. You guys would be driving down and, for example, David might have been Googling original Dickies clothes there. So, what's he going to see on the billboard? Buy a new Dickies hoodie. I won't say what some of you will have been searching. What do we do here? What do we do here? What did you guys come up with? No, I do not want the answer, David. That's why I didn't say, what's the answer? I said, what are you going to do here? What was your first step? So David dealt with inside the brackets first. Did anybody else do that? That's what I would have done too. Because 25 and 100 go together. A and A go together. What do you do with 25 and 100? Divide. What's 100 divided by 25? 4. What do you do with A and 5? Subtract. What's 1 minus 5? A to the negative 4. Why did I move it up to the denominator? I know negatives aren't allowed. Why did I move it up to the numerator, I mean? It might take care of itself, right? The question's not done. That might become positive. What's this guy down here? Negative. So what should I do with him? I'm going to move him up because he may get taken care of. When I move him up, what does he become? Positive. Now all of that is to the 1/2, yes? Where does that 1/2 go? To all of it. So I got 4 to the 1/2. Hey, I know what that is. That's the square root of 4, isn't it? Which is 2. What do I do there? 4 times a half, which is 4 halves, which is, no, you're right, it is 4 halves.
Is that how you say it?
Yeah. 4 halves is 2. So A, it's going to be negative 2, right? And B, what do I do there? 1/4. Now, what there isn't allowed? What's 1/2 times 1/2? That A isn't allowed, so it goes down there. Now I have a choice. How do I write this? Can I leave it like this? If I want to, but what if I ask for it in radical form? How would you write it? 2 4th root B over A squared. Both of them are okay. Everybody good? Yeah. All right. Now, evaluate these. If I'm evaluating, then I'm looking for a number at the very end, aren't I? So, should I put this in for every x and this in for every y right now? Or should I simplify? Simplify. What do I do with 3 halves and 1/2? Multiply? You're just going to say all 4 until I say yes? I'm just going to keep looking at you until you decide on the right one. Why is it add, Ekdeep? Guys, there's no reason to guess this. If I have x squared and x to the 4th, what do? You add. So what are you going to do here? Add. What is 3 halves and 1/2? 4 halves, which is x squared. What do I do with 2 and negative 1? Add it. So that's y to the 1, yes? Now fill in the blanks. X is negative 2. So what do I write here instead of x? Negative 2 squared. Y is what? 3. What is negative 2 squared? 4 times 3 is 12. This one's crazy hard. It's crazy hard. Where should you start? Okay. With this or this? The first thing. What do I do with 4 and 3? Pardon? Multiply. So I've got x to the 4th. That's the first thing. Times what? Negative x to the 12th. Now this is tricky. What is the base here? X, right? Because the negative's no longer in the brackets, is it? Right? But negative x to the 12th. Actually, hold up a second. I don't want to change the way I'm teaching you this. Yes, Emra. Okay. What does this expression really mean? What is really happening with what I've highlighted in blue? And don't write down what I'm about to show you. We're going to talk about it. Can anybody tell me what's really happening with what I had just highlighted in blue? No, David, that's what you're doing, right? Again, what is happening? What's the base in what I've highlighted in blue? Negative x to the 3rd. And how many of them are there? 4. Right? Now what's the base? Negative x to the 12th, right? Okay. Now, listen to me. Is negative x to the 12th the same as negative x to the 12th? No, it's not, is it? Because this is negative, and then whatever is x to the 12th, yes? This is going to be positive, isn't it? Because there's an even exponent with a negative base. Everybody knows that, right? That's what I'm trying to remind you. That's why I said don't write it down, because you've already written it down a bunch. So this is really negative x to the 12th, yes? And all of that is cubed. Agreed? Now, technically, are these the same base? They are, because what can I do with that negative? I can divide it out of there, can't I? I can bring that negative all the way up to the front, and this becomes x to the 4th times x to the 12th. Everybody with me? Now what are you going to do with those? Add them up. So I'm going to get negative x to the 16th, yes? Everyone agree? And all of that is what? Cubed. So that becomes negative x to the what? What do I do over brackets? 48. Right? Is that answer going to be positive or negative? Why, David? I can see the negative right there, and it's got an even exponent. So you're saying that is going to get me a negative answer, yes? What's x, David?
Oh, I thought we were only applying that for 11.
Okay. All right, fair enough. X here, this is negative 2 to the 48th, yes? So what's that going to be? Negative to a positive exponent, what's that going to be? Or negative to a even exponent, what's that going to be? That's going to be positive, and then there's going to be a negative there. So is David right? I've talked you out of your answer, David. Are you right? Look at what we did. Doesn't that negative go positive? Okay. And then there's a negative out in front, so your answer is still negative. Don't let me talk you out of your stuff. Be strong. All right. And that, I don't care about those two. You guys have done those already to death. All right. It is 9:10, 9:07. Break is at 9:15. I have given you have page 227, which on your books is page 106. You have 111, and you have 112. So you got page 106, 111, and 112. Now listen to me. You got 7 minutes right now. I want you to start on that. Again, do a bunch of it. Do you have to do all of it? No, but don't complain if you don't get an A and you don't do all your practicing. After the break, we've got two things to do. I want to do the exponent and radicals review, and I want to do the radicals quiz. Here is what I suggest to you. I will give you that radicals quiz around 10 o'clock. Okay? So you got a lot of time to work on those pages I just gave you, because that will help. Right? And then we'll do that quiz. I'm going to give you about half an hour to work on these pages. Then we'll write that quiz. Then we'll mark that quiz. That quiz is going to be on simplifying. So something like this. Simplify the cubed root of 72. The hardest one on there would be something like this. X to the fourth, y to the third. Simplify that. And there's going to be 3 arithmetic questions. Multiplying or adding and subtracting. Okay? Something like this. Root 63 times root 72. Something like that. Okay? That's the quiz. I want to do that at 10 o'clock. I'll mark it. You don't have to worry about that. After you have done your quiz at 10 o'clock until the next break, you're going to work on this and your review, which starts on page 114. And page 114, we are marking by days. We are marking by day's end. Okay? All the rest of the stuff up there, past radicals quiz, we're going to get to some of it today, possibly all of it. I don't know. Just depends on how the day goes. Okay? Everybody cool? So this is first till 10 o'clock. Then I go to quiz. If you're comfortable with this, you've done a bunch of questions on 106, a bunch on 111, a bunch on 112, and you feel you're good, you've gotten all the right answers from the bottom of the page, go ahead and start on this early. I don't care. But I've given you 2 quizzes on this stuff, and a lot of you have not done as well as you would have liked to. So maybe you're not as good at this unit as you think you are. Right? So make sure you do some good practice here. Okay? Everybody good? Go diddly-o. You got 5 minutes before break. You can get a bit of that done.
I saw your video and I marked this. I just got full mark. Is this the one that you were talking about this morning?
Yep.
Can I just write it down in the quiz then?
I will.
Pardon me?
Huh?
Should I just write this on the quiz? That quiz? This mark?
Yeah. I'll deal with that in a minute.
Okay.
The quiz that we got back.
Yeah.
I got one of them questions wrong. I was right because it's circled right here. I don't think you realize I had it up there.
All right. I'll fix it. Hey, did you get it started? Did you get the van started? Okay. Your key, you can take it apart by holding the back at the top and kind of prying a little on the actual key down or up. And if you can take it apart, hold the back of the key in your left hand, pinch it really tight, like up where the keyhole is, and then pull downwards on the key part and it should pop open. You got that? Okay, now take it out. There should be a little plastic nubbin in the handle part. Pull that out, and then the guts of the key are inside. Take it out. You might need to use pliers. I was able to get mine with my fingers. Well, it might just need a new battery. They're cheap. Take it out, roll the battery around, blow dry it a little on cool, and then try it again. Okay. Bye-bye. Okay, sorry, Ekdeep. Wait.
Good morning, Science School. With the owner of a vehicle license plate number BG.
It's been a while since we've had one of these.
61B. Again, BG261B. Please come to your vehicle and move it. Thank you.
Yes, Ekdeep. Okay.
So for the task, are we just doing this page? For the task, the radical quiz? Is this the only page we're doing, or are we doing all
Right,
stuff?
the radical and simplest form. That page and
All the pages you assigned?
more that page is what the radical quiz
More of that
will
page?
be like. That page. Okay? If you're worried about the radical quiz, guys, check page 103. That's what it's going to look like.
Alright, so we mostly, some of the ones on page 100, we're mostly going to put stuff on page 100.
Now, page 103 is like page 100.
Yeah.